When we think about exoplanets, we often imagine rocky worlds similar to Earth or massive gas giants like Jupiter. However, the true variety of planets out there is almost unimaginable, and scientists have discovered a planet that could be mostly made of diamonds. This is 55 Cancri e. This exoplanet was discovered in 2004 by the now famous planet-hunting Kepler Space Telescope. The planet orbits a sun-like star located around 40 light-years away in the constellation Cancer. That's actually relatively close to us astronomically speaking. It orbits very close to its star and has more than twice the mass of Earth. It's been suggested that the planet may be partly or even entirely made of pure crystallized carbon. And if that's the case, it means that 55 Cancri could be the largest diamond in the known universe, bigger than any diamond ever found on Earth. If this is correct, then there must be other planets out there composed of other precious materials like gold and platinum. But I'm getting ahead of myself. There's a lot that we still don't know about this world. Let's start at the beginning. The first observations of 55 Cancri e came from the Hubble Space Telescope in 2004, but it wasn't until 2012 that researchers were able to determine its mass. They did this by observing how the star's light changed as the planet passed between us and the star. This is called the transit method. It's one of the most effective ways to discover exoplanets, and 55 Cancri e was one of the first discoveries of its kind. What makes this planet so interesting is not only its mass, but also its proximity to its star. In just under 18 days, 55 Cancri e completes one orbit around its star, a year lasting less than 2 weeks. And it gets even crazier. It orbits the star so closely that half of its orbit takes it inside the star's corona or outer atmosphere. So part of every year it receives intense radiation from its star. In fact, the temperature on the side of the planet facing its star can reach nearly 900 degrees Celsius, which is hotter than the surface of the sun. That's because the heat isn't coming just from the star itself, but also from the intense pressure and friction generated by the planet's atmosphere as it's crushed by the gravitational forces of its star. This leads us to the surprising composition of the planet. It's thought that 55 Cancri e could be mostly made up of carbon. We know that because it's so close to its star, it receives a tremendous amount of energy, enough to melt rock and vaporize metals, but it's also under immense pressure. Scientists believe these conditions could cause the carbon in the planet's mantle to crystallize and turn into diamonds. But before you get too excited about mining this planet for gems, I should point out that it's likely covered in a layer of graphite. This is another form of carbon. And based on the planet's density, it seems that graphite could make up about 2/3 of the planet's mass. The rest could be crystallized carbon or even pure diamond. Now, all this is just a prediction based on the conditions on the planet's surface and its proximity to its star. But it's really hard to study the internal structure of an exoplanet unless it happens to pass between us and its star, which is extremely rare. While there's no evidence yet that 55 Cancri e is made of anything other than carbon, it's possible that other elements like hydrogen, nitrogen, oxygen, silicon, and iron could be present in significant quantities. Its atmosphere, for example, could contain hydrogen and nitrogen. But we don't know for sure, and that's why scientists are planning to use the James Webb Space Telescope to observe 55 Cancri e and learn more about its atmosphere. They're hoping to find signs of the elements I mentioned as well as water vapor. The presence of water could help them determine if the planet ever had an ocean. Right now, it doesn't seem likely. That's because the star is more than twice as massive as our sun, and its gravity would quickly pull any water out of the planet's atmosphere and dump it into the star. Plus, the intense heat would probably prevent water from existing in liquid form on the planet's surface. But we just don't know enough right now to say for sure. So while it's fun to speculate about oceans and diamonds, what do we actually know about 55 Cancri e? Well, it's about twice the size of Earth, but it's almost 8 times as massive. This suggests that it's very dense, which is why it orbits so close to its star. If 55 Cancri e had the same composition as Earth, it wouldn't be able to exist in such a tight orbit. The gravity of the star would rip it apart just like it tore Mercury's ancient atmosphere. But clearly it's made of something much denser than our planet. However, astronomers don't think that 55 Cancri E is a pure diamond. That's because if it was, its density would be way higher than what we observe, so it must have some lighter elements in its structure, like hydrogen, nitrogen, and possibly even oxygen. The reason for this is that if a planet is pure crystallized carbon, it's going to be incredibly hard, like the hardest material in the universe, literally. A pure diamond planet would have a surface like the hardest rock you can imagine, maybe even harder than the nuclei of atoms. So if it collided with anything else, it would smash through it like a wrecking ball. We see other objects in space frequently smashing through things, like comets hitting planets and asteroids crashing into each other. But if 55 Cancri E was a pure diamond planet, it wouldn't be able to exist because it would collide with things. Instead, it seems likely that its surface has some softer areas made of the other elements present on the planet. This is all speculation based on models and predictions, though, because again, we haven't explored the surface of 55 Cancri E, and we don't know what it's made of. Another intriguing aspect of the planet is that it's tidally locked to its star. You may remember what happened to poor Mercury, which is tidally locked to the Sun. Well, something similar could be happening to 55 Cancri E. Because the planet orbits so close to its star, it's likely that the tidal forces of gravity have distorted its shape. It's possible that one side of the planet faces the star permanently, while the other side is always turned away. This could lead to extreme weather patterns and make the planet even more inhospitable than it already seems. So while 55 Cancri E might be mostly made of carbon, it's probably not a giant diamond floating around in space like in the cartoons. Instead, it's more likely that it's a rocky world with a hard, shiny crust and an atmosphere that we can't breathe. Maybe someday we'll find a planet that's just a big, beautiful gem. But 55 Cancri E doesn't seem to be that one. There are many other exoplanets that scientists want to investigate with Webb, including WASP 39b, which is a giant gas planet that might have an ocean beneath its clouds, and WASP 12b, which orbits its star every 11 days and receives more radiation than any other known planet. Scientists are eager to learn more about these planets and many others that have been discovered in recent years. But they're also looking forward to the day when the James Webb Space Telescope can finally reveal the secrets of 55 Cancri E and its strange diamond-like structure. Exoplanet research is a rapidly evolving field, and new discoveries are being made all the time. Who knows what other amazing worlds we'll find in the years to come? Maybe we'll even find a planet made of pure gold. Thanks for watching this episode of SciShow Space. If you would like to help support this channel, we have a platform where you can support us directly and get cool perks like submitting questions to our inbox.